Hi folks, and welcome back to Physics with Captain Rod. I'm making this to be to help you out with numbers 5 and 6 in your Unit 1 homework. So let's see what we're looking at here. Find the net force on charge 2 if all charges are 50 millicoulomb. And again, milli means 10 to the minus third. Okay, so this is about charge 2. That's this one. Now, and it's a problem about force vectors, so we should always start by drawing those force vectors. So, ask yourself, all right, how many forces act on this charge? Now there's two other particles. So you've got a charge here, another positive charge, and ask yourself, all right, is it a repulsive force or an attractive force with this one? And that should tell you the force direction. And then you draw a force vector on this charge. Now, at that point, if you wish, you can calculate a magnitude using Coulomb's law. K, Q1, Q2 over distance squared, or I'll just put R squared. And these values are all just basically sitting right in front of you. The distance between them here is 10 centimeters, or in other words, 0.1 meters. Okay. Next, there's a force interaction between these two. Ask yourself, attractive or repulsive force? Once you've answered that, then you can put the force direction on that particle. Draw it in your picture. And consider whether or not you think it's going to be larger than the first one you calculated or smaller. Keep in mind, these all have the same charges. And then you can kind of scale it appropriately. Then calculate a number using the Coulomb's law, K, Q2, Q3 over R squared, nu R. And then the net force is the vector sum of the two. Relatively straightforward, simple problem. Okay, number 6 here. Find the net force on charge 2 if all charges are 50 millicoulombs. So it's the same type of question, it's just two-dimensional, but it's basically the same thing. So again, this one's focused on this charge. Now why? Well, when I write the problems, I just pick one. I could have just as easily said charge 1 or charge 3, but I picked charge 2 for this. Okay, pair of charges here. You gotta ask yourself, attractive or repulsive? Once you know, draw a force vector on this. And at that point, if you wish, you can calculate a magnitude because the charges are given and the distance is given. Next, say to yourself, all right, here's a pair of charges. Ask yourself, attractive or repulsive force. Once you've answered that, you should be able to draw the force direction on charge 2. And you want to kind of think about the scale. You've already drawn the force between these two. Is the force between these two going to be bigger, smaller, or the same? Keep in mind they have the same charges, but the distances are different. Once you have those force vectors drawn, you can draw the resultant, but it's a two-dimensional picture. And I'll just give you a clue. You should end up using Pythagorean theorem and the tangent function to get magnitude and a direction. That should get you through that problem. Okay, same type of problem, just focused on charge 3 really. So now we're focused on this one. And again, just like the previous problem, there's going to be a force interaction between these two. Ask yourself, is it repulsive or attractive? That should tell you the force direction on charge 3. Draw it and then calculate a value. Then, think about the interaction between these two. Ask yourself, is it going to be an attractive or repulsive force? That should tell you the force direction on that charge. So draw it in your picture, thinking about the scale relative to the first force, and then calculate a number. Now, that one has a little side calculation you have to do because this distance right here is not directly given. But I would point out that that distance squared is equal to 10 centimeters squared, I'll leave out the units, plus 8 centimeters squared. Again, those were in centimeters. And when you do a Coulomb's law calculation, what you need are the distance squared in the bottom. Also, don't forget, I did this in centimeters, but if you want standard units and everything to work out, you want to actually put that in meters. So that should get you enough to calculate, ooh, I got a sneeze coming, the magnitude of the force on charge 3. Oh, pardon me. Once you have those two force vectors drawn, I recommend that you write them both in unit vector form and then add them vectorially. That should be enough to get you through those problems. So I think I'll just stop that right there. Have a great day.